Assalamu alaikum everyone. Welcome to Lifelong Learning. Are you struggling to understand how researchers select the perfect sample? Do you want to know how to get accurate, reliable, and unbiased results? Today we will explore complex random sampling, a powerful technique used to improve accuracy and representation in research. Simple random sampling is not always enough. Sometimes we need a more advanced approach to ensure every group in a population is fairly represented. So let's dive in and break it down in an easy way. Now, what is complex random sampling? Imagine you want to gather data from a large population, but simple random sampling is not sufficient. Complex random sampling combines different techniques to ensure that the sample is accurate, efficient, and representative. Researchers use it to handle large populations, diverse groups, and to avoid bias. Think of it like choosing a recipe. Sometimes mixing different ingredients creates the best outcome. There are different types of complex random sampling, and the first one is systematic sampling. Consider a supermarket checkout line. If you count every 10th customer to take a survey, you are using systematic sampling. So, how does it work? At first, you randomly pick a starting point. Then, you select every K-term unit after that. For example, if we are surveying students, you could select every fifth student on a class list. Actually, systematic sampling is simple, quick, and easy to implement. However, if there is a hidden pattern, it may introduce bias. Now, let's talk about stratified sampling. Stratified sampling divides the population into groups called strata based on shared traits such as age, income, or education level. Researchers then randomly select a sample from each group. For example, if you are surveying students, you might group them by grade level and select students from each grade. This method ensures each group is fairly represented and reduces sampling error. However, it requires detailed population data before selection. Let's talk about another sampling method, which is called cluster sampling. Instead of selecting individual people, researchers select entire groups known as clusters. For example, rather than surveying all students in a country, researchers may randomly select a few schools and survey every student in those schools. Cluster sampling is useful for large populations and is less time consuming than other methods. However, it may be less accurate if clusters are not diverse. Another method of complex random sampling is multi-stage sampling, which selects sample in multiple stages, moving from large groups to smaller ones. For example, in a survey of rural areas, researchers might randomly select districts, then pick some upazilas from those districts. At third stage, choose villages from those upazilas, and finally select households from the villages. This method is efficient for studying large populations. However, it requires careful planning. Now, let's talk about the final method of complex random sampling called probability proportional to size sampling. In this method, larger population units have a higher chance of selection. For example, in a national survey, big cities have a higher chance of being picked than small towns. This method is best when population units vary significantly in size. It avoids bias by matching the sample size to the population size but requires accurate population size data. Now, how to choose the right sampling method? Systematic sampling is best for evenly spread populations but may introduce pattern bias. Stratified sampling ensures fair representation but it requires detailed data. Cluster sampling is useful for large populations but may not be accurate if clusters are not diverse. For multi-stage sampling, it is efficient for complex populations but requires careful planning. In probability proportional to size sampling, it is best when units vary in size but requires accurate data. So we have explored complex random sampling and its different methods. Now you know how it works, when to use each method, and the advantages and disadvantages of each. If you found this helpful, like this video, subscribe to Lifelong Learning, and share your thoughts in the comment section. Stay curious, keep learning, and see you in the next video.